Here's lesson 3 on 3D solids. We're going to do a lot of kind of terms and classifying things in this lesson. So prisms are classified as right or oblique. The side faces of right prisms are going to be parallel, which means they don't meet. Okay, so two lines that don't meet. And the sides are going to be perpendicular. So that means they meet at a right angle. All right, so if you think of like the floor and a wall, that's perpendicular. The lateral faces of oblique prisms, they're going to be parallel. But the sides are non-perpendicular, which means they're going to kind of meet at an angle. All right. So this is a right angle here. This is sort of like a different angle, okay? So types of right prisms. The first one here, you look at kind of the front face here. And if you think, what shape is that? Well, that's a rectangle. So this is going to be a rectangular prism. All right. This one is, you could, think, well, this is a square prism, but square prisms have a special name. It's just called a cube. So if you think of a dice. All right, here's another shape. This face here is a triangle. So this is a triangular prism. Again here, this shape here, 5 sides. If you think of the United States, the Pentagon, so this is going to be a pentagonal prism. This one here, 1, 2, 3, 4, 5, 6 sides. That's a hexagon. So this is a hexagonal prism. Okay, we got to classify some things here. So the corner, this is a vertex. Okay. This part right here, that's an edge. And this flat part, that's called a face. Okay, so a rectangular prism, we're thinking about this shape here. How many faces does it have? Well, it has 1, 2, the top, 3, the back, 4, the side, 5, the bottom, and then 6, sort of this front face. Okay, so we have 6 faces. How many edges do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Did I get that right? Okay. And how many vertices? 1, 2, 3, 4, 5, 6, 7, 8. All right, a pentagonal prism has how many faces? Well, we got the front face, that's 1. We got the back is 2. And then it's a pentagon, so there's going to be 1, 2, 3, 4, 5 sides. So 1 front face, 2 back, and then 5 on the all around. So that's 7 faces in total. All right, edges is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 edges. And how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hexagonal prism, so 6 sides around. So let's count the faces. So front face is 1, 2, and then we know that there's 6 kind of around the side, so there's going to be 8 faces. Oops, wrong one. Edges, so there's 1, 2, 3, 4, 5, 6. There's 6 on the other side, so 7, 8, 9, 10, 11, 12, and then 6 around the middle. So 13, 14, 15, 16, 17, and 18. So 18 edges. And then vertices. Let's get a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 vertices. So those are prisms. Then we're going to get into pyramids. Now a pyramid is a three-dimensional solid in which the base is a polygon. So that means like a many-sided face. So, pentagon or a hexagon, etc. Okay? But all these triangular faces meet at one point. All right? And that point is called the vertex. The figure on the left, we need to look at the base. So there's 1, 2, 3, 4, 5, 6 sides. So if we think back, what's a six-sided shape? That's a hexagon. So this is a hexagonal pyramid. Pyramid on the right, 1, 2, 3, 4. Well, a four-sided shape, that's just a square pyramid. Some other three-dimensional solids. This is a cylinder. It has two circles and kind of the same as other circle properties, has a radius, and then the height kind of goes from the center to the center. All right, this one, think of an ice cream cone. It's a circle base that goes to one vertex. Okay, so height, H represents the height, S, which represents the slant height. All right, so there's a difference between the slant height and the vertical height. Okay, you have to be very careful which one you use. And R is the radius. This one is a sphere. It's just basically any sort of ball. The center, so if you think of the very center of it to any point on the outer edge, that's also called the radius. So then we're going to talk about nets of a solid. Now a net is an unfolded shape. So this first one, this is a 3D cube. All right, and this is two possible nets, okay? Now, if you kind of think about how this unfolds, this could be the bottom, and then these are the sides, so four sides, and then this is like the top. So if you ever kind of, you get an Amazon delivery and you have to break down the box to put it in the recycling, you'll kind of know what this idea is. You're kind of folding down all these sides, okay? And then the top also folds down. Here we kind of get some other nets. So you have to look at kind of the unique shape there. So that's a pentagon. So this is a pentagonal. And this shape over here is 1, 2, 3, 4, 5, 6. And that's a hexagonal prisms. Now, you'll notice that this is a five-sided shape. So there's 1, 2, 3, 4, 5 rectangles that are all the same. And this is a six-sided shape. So there's 1, 2, 3, 4, 5, 6 rectangles. So when this all gets folded back up, back into these hexagonal prisms here, or these pentagonal prisms, you'll notice that the rectangles are all the same, okay? And that's because these lengths are also the same, right? These rectangles are all the same because these lengths are all the same. Okay. We're going to get into shapes of a cylinder. Now a cylinder, I'm just going to draw the bottom circle in there. There's two circles. Okay. And if you were to make a slice like this and fold out the middle part there, you'd actually get a rectangle. So to draw a net of this, you would draw a circle, a big rectangle, and another circle. Now this length here corresponds to the distance around the circle. Okay? A square-based pyramid, so you draw a square, and then you draw 4 triangles that are roughly the same size.